Alright, welcome to this video on retrieval augmented generation, RAG, and AI native vector databases. So many buzzwords in the first 10 seconds. So I'll explain what all of that is. And just for some background, you don't need to know a lot about any of these things to understand this. You don't even have to know a lot about LLMs. You just have to have used something. And I assume that everyone has used some sort of LLM. If you've not used ChatGPT, you've definitely used Google search. That is some sort of, it employs some sort of LLM still. So yeah, like BERT is it's not an LLM, but yeah. So let's start with some objective truths that cannot be disputed, that we can all agree upon, that are backed by stats, and these are just objective truths. So LLMs are powerful. We have seen them already in action, like last year and a half, more than that, but last year and a half has specifically been focused mostly on LLMs. Every week there is something new, which is a good thing, which is also a bad thing because there's a lot of bandwagon. It's a phenomenon where someone gives an unpopular opinion for the sake of getting clicks, and then people just jump on it, and hence the bandwagon, right? So LLMs are powerful. There's no denying the fact, right? We've seen what they can do. For example, here's a ChatGPT screenshot that I got from somewhere on the internet. It generates code English, or any language, and not any language, but right now English is much better than any other language, and then it sort of does whatever you need it to do. And LLM has shown another characteristic, these autoregressive models, is essentially that you can set them to a state with prompt engineering. So that has opened up another sort of paradigm for computational linguistics and stuff like that, right? So that's an objective truth. These are powerful systems. We don't know a lot about them yet. That's unfortunate. We don't really know a lot about the most powerful systems out there. For example, ChatGPT, GPT-4, Bard, and stuff like that. But these are powerful. The problem is, and this is also a truth, that they lie confidently. So if given a choice between a system that tells you that it does not know something or it cannot do something, versus a system that does not know it and yet blatantly lies with confidence, so which one would you choose? I personally would prefer the first system because it's much simpler to make decisions based on its outputs. And I think even statistically, those systems would be better and less dangerous even. So ChatGPT has been known to make stuff up, but not just make stuff up, it can also make sources up. So for example, most of these links, if not all, will go to 404, and these don't exist. But as an amateur, you don't know about the fact that these models do hallucinate. As an end user that is not too technical, you will take one glance at this and you'll feel like, wow, that's an objective fact, that's a truth, because it is backing it by a lot of links. So you might open first link, it goes to 404, you're lucky, now you're skeptical. But what if you open the first link, it is an actual link, but the rest of them are 404, so you don't bother clicking them. So you've formed an opinion based out of misinformation, which means that you will always be wrong about this, or at least unless corrected, right? That is second objective truth. They lie confidently. Third objective truth, LLMs continue to be a black box. Now, I hate this generalization and these buzzwords like black box and stuff like that, but this was not true when we used the term black box for neural networks, because we obviously understood how neural networks worked much more deeply than we do with LLMs. But that's an objective truth again, that powerful LLMs out there that are totally closed source, we just have an API access, these are black boxes. And the way to interact with them is a prompt or an API that again is simply in other way a prompt. So these prompts are powerful. Not to dispute the fact that these are really powerful and useful. These continue to be really powerful. But you input something and you get an output. And in between there's a black box or an orange box in this case, right? That you don't know anything about. You cannot peek into. You cannot see what's being updated really. And overall you don't understand much about it. Now, you can see why this is a problem, or this can be a problem, but yeah, we'll focus that in the next slide. So I guess not. We have to focus about the problem here. So okay, looking at this, one thing that's really clear is there are multiple ways in which you can think of this, but the general theme is that there is something that needs to be improved, because there are many terms to address it. But let's just say, if you should never have all your eggs in one basket. So essentially this means that one part of your pipeline breaks down because it's a black box. You don't know what to do first thing, right? And so you essentially have outsourced the entire operation, your entire stack, to something that you can only access through an API. You have no say as to how these systems are trained and improved over time. You have no say on the iteration of these models. And you never know if the data that they are trained on is the right kind of data, right? So a lot of things can go wrong here, not just technical, but some things that are related to legality of things can go wrong. And if you base your entire service on top of these systems, it's not to say that it's you should not do it. If you're doing it, it's totally fine, but there is a risk, right? That if something isn't right, or let's just say that if something isn't wrong, it does not make it right? So it's there's something that we have to figure out here. So this is where sort of RAGs, or retrieval augmented generations, come in. So this essentially means that it does not rely on LLMs being end-to-end systems. You definitely rely on LLMs to represent your data, your information, but then you control the algorithms and the operations that take the piece of data, connect them together to form the final output. Here's an example. Let's just say you have a knowledge base that is in terms of documents. Using an LLM, you have basically embedded that. So you essentially represented all of those documents in a vector space. Right? This vector space can be really high dimensional depending on the model that you're using, or the LLM that you're using. But essentially you're using these LLMs to not get you the response, but to only get you the representation. That is the key here. Once you have these represented, you use your own retriever. And these retriever, let's just consider them a black box for now, a slightly smaller one. Because you know it's only operation, and you most probably will know how this works, because this is pretty much out there. It's one of the research areas in computer science, so you know how these work. These are not at all black box, but for this example, let's consider that, right? So instead of performing end-to-end query on an LLM where you give a prompt and you get the final response, you take that prompt, you go to your representations, using the retriever, find the best, most relevant relevant responses, sew them together to a response that can then properly cite without lying, without making stuff up, and help you trace back those sources on how this response was generated. This is much more powerful. This is much more modular, because you can replace an LLM that you're using for representation. You can replace the retriever. You can replace the algorithms in retriever. You can even build something custom on top of it, right? And you also control how or the format in which the final output reaches the user. So that is really important. That's the key here. Okay. So why this is really important to not use LLM end to end, but break it down into smaller problems that are well explored. This is a quote that's one of my favorite quotes. I totally agree with this. I heard this quote almost 8 to 9 years ago, and it says, "It is artificial intelligence as long as it doesn't work. It's computer science as soon as it starts working," right? Now, I think, like, I went back and checked. I couldn't find the video exactly, but I think this was said by Eric Schmidt uh, in some Stanford, guest lecture. So I'm not sure about this, but yeah, this is where I remember it from. But if it's not the case, then I'm happy to take credit for it. But I'm pretty sure it was him. So okay, so why this change in domains is important? What I mean by change in domains is this: when you're dealing with large language models, it's a new paradigm. It's not been explored yet. When I say it's not been explored, it's totally not been explored, right? You might say, well, there are some open source alternatives, but those alternatives don't go as far. Those alternatives don't work as well. They might get there in 4 months or in 2 months. We're not sure. It's a very fast moving field. But the idea that there is a model out there with trillion parameters. So if that's the truth, there's another truth that comes out of it, that just spins out of it, is that there's no way in the world we understand how a trillion parameter model works. There's just no research done in that direction, no exploration done in that direction. So change in domains from a black box trillion parameter model to another approach. It's changing the problem statement in a way that we build a solution that comprises of small modular blocks that have been explored for years, and I would say like for decades. That is the idea, right? So we move from black box to modular components backed by years of research and exploration. This is important because now we do understand how to iterate. Now we do understand how to move forward in improving these systems, and we do understand if something breaks down, where to look, right? That's really important. That's the key here. These are different fields like information retrieval, ranking, indexing, things like that a lot of research has gone into, a lot of dollars have gone into, right? So the first thought that comes to mind is, to do all of this, I need to spend a lot of money, right? Well, that's not necessary, because what you get out of that is you get a lot of things, right? With LLMs, you didn't get any of these things. You get some interpretability, some modularity, some control as to how you want to improve your system if something regresses. And then there's retraining cost, right? So all of these things, right? These things are pretty important and are pretty standard. These are measured. It's just not straightforward to say how much value do I create in terms of like real concrete value when I'm able to interpret my models, right? So how much efforts should we sink into interpretability? Same about modularity, right? How much do you save or make on good engineering principles? That is, that is across the domain, right? Like, people want to write good code. People want to follow best practices when it comes to ML, which is MLOps and stuff like that. Companies want control over what they do. No one should be able to flip a switch somewhere outside and control everything that a company has to do or a product has to go through. And retraining cost. Obviously, you will see data drift. You will see all of these sorts of things. You have to think about, you cannot have a model that you can only manage to train once in a decade. So all of these things are really important. When you think about this, then increasing cost a little bit one time should not be a big deal, because that is going to make up for itself. So let's talk a little bit more about retraining cost. So a question that I would pose is, what is cheaper? Training a new large language model or simply reindexing your knowledge base? Because this will happen. If training has been cut off, the model will not learn anything new after that date. So, and the rate at which we are farming data, it is going to be really crucial to train an LLM again if the cutoff date is somewhere around 2020, right? We're not sure how fast things will change in this fast moving world. So that would be much more costly, much more expensive compared to simply running your entire knowledge base through a large language model that could essentially represent it in your desired vector space, rather than making sure that LLM understands semantically and answers your questions end to end, because that would require to retrain it completely. This is not talking about representation. This is a thing. This is about response versus representation. That's a great line. I should have thought of it before, but anyway, what we're dealing with is response versus representation. Now let's come to the need for AI native databases. What do I mean by AI native databases? Right? It's just a bunch of buzzwords? Not really. Right? What does AI native mean is AI native means that it should be designed, and the decisions that are taken along the way of its design should be catered towards artificial intelligence and the data that it needs, essentially deep learning here, not traditional artificial intelligence algorithms, because those are essentially, some of them are don't even require parameters. So we'll not go there. Here AI is mostly deep learning or multimodal LLM, stuff like that. So AI needs data, and a lot of data, right? And as I said before, the rate at which we are farming data is going up. So every action a user takes on any platform, from scrolling to click to just staring at screen and not doing anything, has become a data point at this day, in this day and age, right? So we do need a database that can store lots and lots of data and do that efficiently, right? It should not break the bank. That's the third point. Models are becoming multimodal. Data needs to follow. What this means is that you need to find out ways to make sure that you can store various kinds of data efficiently and easily, right? There should not be complexity about whether it's unstructured or structured, because we are way past that. That debate is over. Models are now able to parse anything and everything, so databases need to follow. And finally, we have to do all of this, but we have to also remember that ML engineers don't need to learn yet another field of tools, right? We have seen that with ML ops, we have seen that with LLM ops, we've seen that with a lot of things, right? So that's one thing that we should try to avoid, because it just is becoming like a diarrhea of tools. Like every domain has 50 tools to choose from, and you learn one, it turns out the other one is probably becoming a market leader in 2 years, and then that's a mess, right? We don't need that. So finally, like I'm gonna say that I'm gonna chill a bit. So I'm working on LanceDB team, and we sort of look at this problem, and this is why we're working on this, right? There's a huge gap here. So what does AI native vector database means here is that there's so many things going on here, right? We have to store data, and we have to store it efficiently, and we have to make sure that it is AI native, which means it is designed for these kind of uses, which is representation of unstructured data in a vector space, and then easy access to it, and storing it in a way that is cheap and inexpensive for scaling. And so we'll see all those 3 points here. First thing is that all of the data that is stored using LanceDB, it's in persistent storage, right? So it's not basically using your RAM to scale. It's in your hard drive, and you can essentially scale with your hard drive. So it's not going to break your bank, unlike most of the other tools out there. It is serverless, which is the control aspect. You have all the control in the world on your data and your database, your vector database, right? And then finally, we don't want you to learn yet another tool, yet another API that is more and more complex. If you're using Python data ecosystem, which you most probably are, if you're doing machine learning, well, then keep using your your data formats that you're most familiar with. You're using Arrow, that's fine. You're using Pandas, that's fine. You're using Pydantic, that's fine. If you're just using native Python lists and dictionaries to communicate between your services, that is also fine. You can simply ingest every of those formats. If you're a developer building apps, well, you can also ingest JavaScript objects there. And the good thing is that you can also get these formats, the data back in any of these formats as you like. You can run semantic vector search, you can run SQL queries even. And obviously it's persistent in hard drive, so you don't have to care about how much memory you're going to use and whether it's going to break your bank. And this is a big problem, right? This is a new technology. A lot of companies, go in headfirst and then just starts using any of the tools available out there. And after a while, when there's so many vectors to store, so much data to store, so many feature stores to build, they realize that scalability is a problem. And obviously it is, because it's a new field, right? So scalability has to be a problem no one has thought about yet. So that essentially is why LanceDB is the AI native database, vector database, and probably the only one. So that's pretty much the talk. I hope I did not sell on LanceDB too much, but it's really cool. You should check it out. And yeah, this was essentially a different format. Like I'm not coding stuff, but yeah, this is a point that I wanted to get across, and I've been seeing across LLMs and the trend in general. So yeah, let's head out. See you guys in the next one. Bye.